Good morning, guys. Happy Wednesday. Sorry I'm not with you this morning. I have a dentist appointment. So I'm getting my teeth cleaned, which is not very fun. I'd rather be at school, believe it or not. But anyway, we're just going to pretend like we're having class, but on this video. So you should already have your binder, pencil, your expressions and equations packet. So we're going to start with your bell ringer in your binder, just like we normally do. So go to day 65 of your bell ringer, and it should look like this. Oops, not like that. Like this. Okay, so go ahead and solve those problems. Remember, you have a calculator, so you can use those if you would like to. And pause the video to do this, then we'll go over the answers. So yes, I want you to actually pause the video. I know some of you don't pause the video when I tell you to pause the video, but I'm telling you to pause the video right now to do your work on your own, so pause the video right now. Okay. Oh my goodness, thank you so much for pausing the video, like I said, and let's go over what these solutions are. So -6 times 5.7. So you have a calculator. When I do this in my head, I break it up into two pieces. I do 0.7 times 6, which I know is 4.2. It's just 7 times 6, and then you move the decimal over. And then I also know that 6 times 5 is 30. So then I just like combine the whole number and the decimal piece together, and you get 34.2, but you have one negative and one positive, so the result is a negative number. You can also just do the stack multiplication if you would like. That would give you the exact same result, so you can do that too. And of course, you guys have calculators, so you can be checking your work. I'll check my work right now too, just to make sure. 5.7 times 6. Yep. All right, cool. So the next one is 13 times, negative 13 times negative 9. I don't know my 13 multiplication facts very well, but it is 117. And you have a negative times a negative, so of course that comes out to be positive. All right, the next one, 49 divided by -7. So you have one positive, one negative, so the result has to be negative. 49 is a perfect square of 7, so the answer is 7. -7. Okay, two fractions. You're going to do keep, change, flip on these guys. So keep the first one, change division to multiplication, and flip-a-roo that 1/3 into its reciprocal, 3/1. Okay, so whenever you have fractions that you're multiplying, you just multiply straight across like that. And so you would have -3 times 3, which is -9, over 5 times 1, which is 5. And remember that negative can be in the numerator, the denominator, or outside the fraction. They're all the same. So it should be -9/5. Okay, Pascal, on a soccer team, 40% of the goals are scored by the star player of the team. If 70 goals are scored all season, how many are scored by the rest of the team? So with percentages, remember the key idea is comparing the part to the whole. So let's look at what we've got. We've got 40%, we've got 70 goals for the whole team, and then, 70 goals are scored by the whole team. So you're trying to find how many are scored by the rest of the team. So the rest of the team would be not the star player. It's the worst star I've ever drawn. Okay, not the star player. So let's go ahead and start figuring this out. So if 40% are scored by the star player, so 40% are scored by the star player, then the not star players score that other part that takes us up to 100%, right? So that would be 60%, because those two things add to the whole 100%. So we're looking for how many were not scored by the star player. 70 goals is the total for the whole team. So that's like your whole. So let's start setting up our percent out of 100. So we have our percent out of 100 is equal to our part out of the whole. So let's start going through this. So the not star player percentage is 60% out of 100%. And we're trying to find how many goals that is for that the rest of the team, the not star player part of the team, if 70 goals are scored all season. So 70 is your total. Okay, so you guys have calculators, so you probably did this. You did cross products. And 60 times 70 divided by 100 is 42 goals, I do believe. You guys can check my work, but yeah, let me just double check myself. 60 times 70 divided by 100. Yep, 42 goals would have been scored by not the star player. So just be careful that you're answering the question that's being asked. 42 goals. All right, guys, go ahead and go to your daily dose now. 75.8 times 0.12. I have someone in third period who uses this strategy, and I think it's really good. So I'm going to show it to you. He treats these numbers just like regular old numbers. So he kind of just removes the decimal, which works because with decimal multiplication, you don't really care about the placement of the decimals. You only care about the decimals at the very end. Oh no, my pen's doing that crazy thing where it draws all over the screen. Okay, let me back up. So you can just stack them up and multiply them, and then we'll do the decimal work right at the end. So you could do lattice method if you prefer. 2 times 8 is 16. So 11, 2 times 7, 14, 15. Placeholder 0, 8, 5, 7. Add it all up. 6, 9, 10, 9. Okay, so when I did it, I got 9,096, which obviously doesn't make any sense because I'm taking like about a tenth of 75. So that's like way too big. So it's because we still need to move the decimal. So when you do this method where you just ignore the decimals at the start, at the end, you just got to go through and count how many decimals there are. 1, 2, 3. So I'm going to move it up 3 spots. 1, 2, 3. So you should get 9.096 as you're solving this. And again, let me just check that I've done my math right. But yep, so 9.096, which makes a lot more sense. That's definitely closer to what our answer should be. Okay, so go ahead and get out your expressions and equations packet. Today we are going to learn how to solve one-step equations. So before we start, I'm going to tell you guys a little story. I used to play soccer in high school, and well, I used to play soccer all of my days growing up. But in high school specifically, I had this coach. His name was Coach Phil. And he told us one practice that we were going to do conditioning the next day. So we needed to just be aware of what we were eating because practice was going to be super hard. And so the next day rolls around and I leave high school at I think we got out at 3 or something. And then practice didn't start till 4:30. So I was hanging out with my friend. And of course, we were hungry, so we decided to eat a bunch of snacks. And I just decided that what my coach told me didn't really matter. I'd be fine. So we all pounded a half a box of Cheez-Its each or something crazy. And then we showed up to practice at 4:30. And to start practice off, we were going to go on a 5-mile run as a team. And it's 85 degrees because it's the middle of September in central Indiana. So we're on our run. We're 2 miles in. And you know what? I didn't listen to my coach. And I ate all those Cheez-Its. And you know what happened? Right in the middle of Summer Winds Estates on some poor citizen's driveway, I just threw up Cheez-Its everywhere. And I couldn't finish the run because I was cramping so bad. And I had Cheez-Its on my shoes. It was just a bad situation, right? All because I didn't listen to my coach because I thought I knew better. But the reality is my coach knew better. He knew that much conditioning, you needed to make sure you knew what you were eating. He knew it was going to be super hot outside. And I just didn't listen to him. So I threw up Cheez-Its everywhere and I couldn't finish out the practice. So you might be wondering, why am I telling you this story about throwing up Cheez-Its? Here's the reason. Today I'm going to teach you method for solving equations. And I want you to trust me. I am your coach. So I want you to listen to what I'm saying and follow my process because it will make life so much easier as you go through the rest of your mathematical career. If you don't do what I'm saying today, if you don't follow my process today, then you're going to be throwing up Cheez-Its all over your math books for the rest of your math career. And I don't want that for you. So trust me, trust me, trust me, trust me. Do as I do. Okay. Go to this page in your packet. How do you solve a one-step equation? Should be right after everything else we've done. Alrighty, so here we go. In order to solve an equation, we must isolate the variable and keep each side balanced. To isolate the variable means to get the variable alone. Something that's isolated is alone. So our goal is to get an equation solved so that the variable is by itself. And keeping each side balanced is really important in equations because for it to be an equation means that both sides are equal. You can imagine a scale that's perfectly balanced. And let's say on this side, there's a 5 gram weight sitting on it. Well, that doesn't mean the other side has to look exactly the same, but for it to be balanced, if these were all 1 gram weights, there'd have to be 5 of them on the other side. That's how this would stay balanced and equal. It doesn't mean it looks identical. It means it has the same value on both sides. That's what equality means. So we have to maintain that balance and that equality. I'll show you how we're going to do that. But first, in order to maintain that balance, we are going to use inverse operations today. So the inverse operation, or the opposite of addition, is subtraction. So the opposite of subtraction is addition. The opposite of multiplying is dividing. And the opposite of dividing is multiplying. Okay, so these two are inverses and these two are inverses. So inverse operations can be thought of as the opposite or undoing operations. Subtraction undoes addition. Multiplication undoes division. They're opposites. We're going to use them to undo an equation, to solve it backwards. So there's two key questions that you have to ask yourself. The first one is, what operation is taking place in the original equation? And then what is the opposite of that? Because that's what you're going to use to undo it. Okay, so let's go down to some example problems. It says use inverse operations to solve each one-step equation below. So number 1, 4x equals negative 16. Some of you know off the top of your head what the answer to that is already, and that's awesome, but that's not what I want your main focus to be today. Today, the main focus is learning the process for keeping an equation balanced using inverse operations. So here's how you're going to do it. You're going to start by drawing just little dashy lines down the center of the equation. That is going to keep your two sides totally separate so that you only apply an operation once on each side. You're going to help you maintain balance. So the first question is, what operation is being used? So in this problem, the operations that's being used is multiplication. So what is the inverse of multiplication? It's division. We're going to use division to undo this. Here's how you show your work. 4 times x. We're going to undo by dividing. Divide by 4. Now, what I just did to the left side of the equation is I brought it down. I lowered it by division. So my equation is unbalanced right now. The way I rebalance my equation is by dividing the other side by 4. You only do the operation one time to each side, but you have to do it to both sides. So what ends up happening when you do this? Well, 4 divided by 4 is the same thing as 1. 4 over 4 is just 1. So what we end up with is 1 times x And that's equal to negative 16 divided by 4, which is negative 4. 1 times x, 1 times anything is just whatever that value is. So we're just left with x equals negative 4. So that's what we're saying that variable is. It's no longer a mystery, but that's what we're saying that number should be. So now what we're going to do is we are going to check that we're right. So here's how you check your work. You had this original equation where you said you didn't know what this variable was. Now we're saying we think we know what it is. We think we know that x is negative 4. So we're going to take negative 4 and plug it in anywhere that we see an x. And if we've solved the equation right, we should get a perfectly balanced equation. So let's do this. 4 times negative 4, that's what we said x was. Does that equal negative 16? Okay, so yes, it does. Negative 16 is in fact negative 16. So we know we've done our work correctly. When we plug in our answer for x, we get a perfectly balanced equation. If you solve it wrong, you'll get something that doesn't make any sense. So let's keep going. Let's try again. X plus 9 equals 13. Draw your dividing line to help you keep your sides split. So what operation are we using to start with? Addition. We have to undo addition by using subtraction. And here's how you can show those steps. I am going to subtract 9 from both sides. Here's how you show that. You're going to write it right below the adding 9. And whatever I do to one side, I have to do to the other to maintain balance. So I should see a subtracting 9 on the left and a subtracting 9 on the right. Then we're going to draw a line like this. So what ends up happening? Well, my x is still there, and I'm adding what? Well, 9 minus 9 cancels out because it's just 0. So we have x plus 0 equals 13 minus 9. Well, that is 4. Anything plus 0 is just itself, so we're left with x equals 4. We're going to go through now and check that we're correct. What we're saying is that we think this x is 4. And you guys know, I mean, you can tell just by looking at it that we're right through guess and check, but I don't want you to use guess and check anymore. So x is 4. We're going to plug it in for x. And we should be able to prove that we're correct. Proving you're correct is really important in math and in life. So you get two sides that are totally equal, so it works. All right? Don't write down what I'm about to write down in green, but I want to show you guys something. Let's say we solved this equation and we got x equals 10. You made a mistake, you got x equals 10. But you don't know it's a mistake. When you go to check your work, here's what would happen. X plus 9 equals 13. You would be plugging in that thing you think x is, 10, and you'd get this. 10 plus 9, 19 equals 13. That doesn't make any sense because your answer is not correct. So if you check your work, you will be 100% confident that you're right. If you get something that doesn't make any sense, you need to solve it again. Okay, let's practice 2 more together, and then you're going to do 2 on your own. All right, so draw your dividing line. Okay, we have x minus 8 equals 4. You have to undo subtraction. So we have subtraction, we're going to undo it using addition. We're going to write adding 8 right below the original subtracting 8. Whatever I do to the left, I do to the right. And I'm going to draw a line underneath of it. So what ends up happening? It's like a giant addition problem. We're going to add these things together. So we carry this x down. We have minus 8 plus 8. Well, that is just going to cancel right on out, and it turns into a 0. On the other side, we have 4 plus 8, which is 12. X plus 0 is just x, so that is equal to 12. Check your work. Plug in what you think the answer is. Some of you think you can skip this step of checking your work. That would be a mistake. That wouldn't be trusting me. That would be throwing up Cheez-Its all over your math work. So don't do that. Okay, when you check, it works. It's good. Okay, let's do another one. So, number 4. This is when you're starting with division. So draw your dividing line. We have x divided by 5 equals negative 6. So we have division. What's the opposite of dividing? It's multiplying. So here's how you show your work to do multiplication. You're going to multiply both sides of the equation by 5. So the entire left side is going to be multiplied by 5, and the entire right side is going to be multiplied by 5. Make your little multiplication symbol small so you don't confuse them with a big X. Okay, so what happens? What you have here, you don't have to write this out every time, but let me just show you. What you have is 5 over 1. So when you have 5 times something that's being divided by 5, these are going to cancel out to a 1. 5 over 5 is just 1. So you have 1 times x equals negative 6 times 5. So it's 30, but then it's negative. So we have x equals negative 30. That's what we think the answer is. Go ahead and check. You rewrite down the original equation, x divided by 5 equals negative 6. You plug in what you think your answer is, negative 30 divided by 5. Is that negative 6? Yes, it is. I'm running out of room because of my picture, but negative 6 is negative 6. So you know you've solved it correctly. I want you guys to try 5 and 6 on your own. Okay, check 5 against my work. On number 6, you need to be careful. It's multiplying, but you need to divide not just by 2, you need to divide by negative 2. Take that negative along with you. Okay, once you are done, you can check your work against mine. So make sure it looks very, 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 very similar. You need to be showing these steps and these processes, and you need to be checking your work. This is everything that's expected. And I know it seems like a lot right now because these equations aren't that complicated, but as I said, you're going to be getting more complicated equations where you're doing 2 steps, 3 steps, 4 steps. And you need this for the rest of your math life. So you need to make sure you're doing it as I'm showing you. Flip on over to the next page. So one-step equations can also include rational numbers. So it can have fractions and decimals, positives and negatives. So you're going to go through and you've got to solve it just the same. And this is why the process can be so helpful, because you might not know off the top of your head through guess and check what the solutions are to rational problems. But if you use your method, you can always figure it out. All right, so let's do 7, 8, and 9 and 10 together. We're going to move a little faster now. So 6 times x equals negative 16. I'm going to use division to undo that multiplication. So 6 over 6 is going to cancel out to a 1. And I'm left with 1 times x equals negative 16 over 6. So x, if you simplify it, is negative 8 thirds. I just divided both of them by 2. So if you go and check your work, you have 6 times x equals negative 16. So 6 times negative 8 thirds, does that equal negative 16? And let's see, you would multiply your numerators. 6 times negative 8 is negative 48. And this is like over 1 times 3, so over 3 equals negative 16. Yes, that does work out. That's correct. So we've definitely solved that one right. All right, move on to the next one. Draw your dividing line. You need to subtract. You're adding, so you got to do the inverse, which is subtract. You show that by taking away 2.5 right underneath of that other number. And so here's a question. Why don't we take away 7.5? Why don't we take away 2.5? Right, because we're trying to get x alone. That was our big goal, right? We're trying to isolate x. So we want to get everything away from the x variable so that he's all by himself. That's our big goal. So we got to make sure we're doing our work to accomplish that goal. So we're left with x plus 0 is equal to 7.5 minus 2.5 is 5. So we have x equals 5. Check your work. X plus 2.5 equals 7.5. So is 5 plus 2.5 equal to 7.5? Yeah, it is. So you've done your work correctly. We've solved it right. Check and circle. Okay, let me show you this next one. It's kind of unique. 2/3 x. So what we have is a fraction as a coefficient. So you're multiplying and you're dividing, but there's a little bit of a trick with fractions, and the key is to use reciprocals. Because anytime you take a fraction like 1 over a, and you multiply it by its reciprocal, a over 1, the answer is 1. So we can get rid of that left side number by using reciprocals. So what is the reciprocal of 2/3? You just flip the fraction upside down. It's 3 over 2. So if we multiply both sides by the reciprocal, remember to do it to both sides of your equation. Boop, 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 boop. Here's what's going to happen. 3 over 2 times 2 over 3. Those are reciprocals. They cancel out to a 1. So you're left with 1 times x equals 8 times 3 halves. Multiply your fractions, so it's 8 over 1. 8 times 3 is 24 over 1 times 2, which is just 2. So x should be 24 divided by 2. X should be 12. So we're going to check that we're right. Is 2/3 of x equal to 8? So is 2/3 of 12 equal to 8? Yes, it is. 2/3 of 12 is definitely equal to 8. You can prove it. 24 over 3. Does that equal 8? Yes, 8 equals 8. We know we've done our work right. So using reciprocals is key on this problem. Okay, I want you guys to go through, try 10, 11, and 12 on your own, and I'm going to go all silent here, but be showing my work up on the screen. You need to ask yourself, what is the operation being used already in the equation, and how do I undo it? All right, guys, you should check your work against mine. Make sure it looks so similar so that you're doing these correctly. One little tip on number 12, you want to make sure you're dividing by -4. And then why is -2 over -4 1/2? Well, you have two negatives, so they end up canceling out. So -2 divided by -4 is the same thing as 2 over 4. It's two negatives make a positive, which if you simplify it is just 1/2. So that's how we get 1/2 from -2 over -4. Okay, let's do one more problem. Oops, let me jump ahead here. Let's do one more problem together. It's on the very bottom. So word problem, and then you're going to move into some practice. So if a chocolate pie is divided into 6 equal slices, and each slice has 280 calories, how many calories are in the whole pie? So let's go through and underline any numbers that you see. Whole is like not really a number, it's kind of a number, so I'm going to underline it. So I know that I started with a whole pie. I'm going to call that P, the whole pie. And then I had 6 slices, they're all equal to each other. And then I had 200 calories. So the question is, how many calories are in the whole pie? So that's what I need to know. Calories in the whole pie. Got to figure that out. So here's my plan and my work. You have this pie that you're starting out with. So here's my pie. Ooh, maybe it's pumpkin pie. Okay, so there's the pie. That's P. The whole pie is P. And we're told that that's divided into 6 equal slices, right? So do your best drawing this into 6 equal slices. But there's my 6 equal slices. Okay, so 6 slices. So what I've done is I've taken the whole pie, I've split it into 6 slices, and I'm told in the problem that each of these little slices is 280 calories. 280 calories, right? So when I start with the whole pie and I divide it by the 6 slices, what I get is 6 little individual slices that have 280 calories in them. So how many calories are in that whole pie? We're going to use inverse operations to solve. So you're going to multiply both sides by 6 to undo this division, right? You do it to both sides of your equation. Okay, so my 6's are going to cancel out, and I'm going to be left with 1 times that pie calorie amount, and that's equal to 280 times 6, which I believe is 1680, but let me check on a calculator. Could be way off. No, I was right. Oh, snap. 1680. Okay. So P equals 1680. So remember, P represents the total amount of calories. So there's 1,680 calories in the pie. Boom. Okay, that's what the end of our lesson is today. So now you guys are going to practice on a little worksheet. So you're going to use the notes that we just took. You just had a lot of problems that show you how to undo multiplying, dividing, adding, subtracting one-step equations. And the guest teacher has the handouts for you. So when you're done with this video, you need to walk your little body on up there and ask them for the worksheet. Here's my one last plea to you. Be sure to solve the problems using the method I taught you. This is vital. It is vital for the rest of your mathematical career. Don't be lazy. Do you hear me? Don't be lazy. Don't take shortcuts. Just trust me. Trust me. Trust me. Okay? Don't be lazy. Not saying that you are lazy. Don't make a lazy choice. Okay? Go get your worksheet. And then once you finish that worksheet and it's got the things it needs, the balance equations work, checking your work, then you can start homework 14, which is on Canvas. So you can get to it there. Okay? All right. I will see you guys either in the hallway this afternoon or I'll definitely see you tomorrow. Bye.